Okay, so we worked out the magnetic field along the axis of a loop. It was a complicated calculation. How can we check it? Well, we already checked it in one way. We worked out right at the beginning which way the magnetic field was going to go from the right-hand rule, and this agrees with that. So that's one good check. A second way of checking would be units. So what are the units here? Well, mu naught has units of Tesla meters per amp. You can look that up. The constants, pi's, 4 have no units. Then we've got an R squared, so that's meter squared current, which is amp. And at the bottom you've got Z and R, which are both distances squared. So you've got meter squared or to the 3/2 power, which will come out as meters cubed. So what's going to go on here? Well, the amps cancel. Got meters cubed on the top and the bottom, so that cancels. So it comes out as Tesla. So magnetic field in Tesla, which is good. That's what we want. So tick. How else can we test it? Well, the other way is often limiting cases. What's a limiting case here? Well, the most obvious limiting case would be right in the middle of the wire loop. So if we have a wire loop here and we're trying to measure the magnetic field right in the middle, well, in this case, all bits of the wire, their current flowing like this, they're all going to give you a magnetic field that goes at right angles like that. And we know what that magnetic field from a bit of a wire is from the Biot-Savart law. It's going to be mu naught over 4 pi I delta L over R squared. So we just need to sum that up over the entire circle, because they're all going to be the same. Delta L all around the whole circle is just going to be 2 pi times the radius. So if you replace that with 2 pi R, that cancels out with one of the R's over there, and that comes out as mu naught over 4 pi 2 pi I over R. How does that compare with this? Well, if we set Z equals 0, that comes out exactly the same. You just get R squared to the 3/2, which is R cubed at the bottom. So you're going to get 1 over R, and everything else matches. So this rather simple limiting case also works. So this is looking plausible.